Hi and Assalamualaikum. May I introduce my name is Nuri Izani binti Kamarudin. My metric number is CN180065 and my supervisor is Dr. Nurfiza Idris Bidalis. So today I want to present a thermal analysis of heating-pad application using the computational fluid dynamics. Okay, next for the research background. Okay, next for the research background for the flexi tank and the heating pad. So what we know, the flexi tank used as a transport bulk liquid item from one to another place. So it also used the heating pad as a support the transport bulk liquid, and we know the heating pad allow the maximum exposure to the heat source. So the steam also can properly discharge from the outlet tube and slowly increase the steam pressure in the heating pad. So they use two materials which are steel and EPDM rubber to flow the heat source through the heating pad. So the working pressure for the heating pad is 15 psi or 1 bar, and the temperature range for the heating pad is 100 degrees Celsius to 120 degrees Celsius. So the heating pad also temperature melt in 48 hours. Next for the problem statement and the objective. Next problem statement. So for the problem statement, first the heating pad process of the reheat took over 1048 hours. Take time to liquidize the liquid inside the flexi tank. Lack of the detail for the optimum capacity used for the inlet pressure. Lack of the detail optimum operating inlet pressure, and uncertainty of the regarding the heating pad thermal efficiency. For the objective is first to determine the critical thermal parameter of heating pad on different inlet pressure. Second, to compare the effects of the heat distribution with different heating pad tube thickness. Next, for the scope of study. Next, for the scope study, first the investigate focus on the heating pad as the model for the CFD simulation. Second, the heat distribution was analyzed through the various inlet pressure parameter, which are 1 bar, 2 bars, 3 bar, and 4 bar. Next, the heating pad was designed by using the CAD software. Is SolidWorks with the different thickness of the heating pad tube, which are 3 mm, 4 mm, and 5 mm. For the last, the data was establishment of the heating pad efficiency were obtained by from the CFD only. Next, for the literature review. Next, for the literature review, number 1 is heat transfer of the heating pad. So from the summary from this literature review, most of the heating pad use the same heat source. The heating pad variable built for the heat transfer to another heat source and different materials. The heat source was generated to achieve the pressure and temperature met the optimum of the heating pad. So next, for the literature review number 2. So for literature number 2 is the thermal performance. So from the summary from this literature review, the additional difference of heat transfer will be as a reference. The improvement of heat transfer will be achieved. It can be assessed the suitable of the heat transfer for the temperature and pressure. Next, for the literature review number 3 is the type of heat transfer. So from the summary of the types of the heat transfer, we're simulating the effects of the thermal load on the solid by the observing the temperature and the pressure distribution. That the way to increase the heat transfer. Heat transfer always transfer in the direction of the decreasing temperature. Okay, for the literature review number 4 is the computational fluid dynamics. Okay, based on the previous study, they used the different software in the temperature, heat source, and the materials. So first for the previous study, they used the star CCM plus and the 15 degrees Celsius for the inlet temperature. They use the electric current in the Laurentian interface for the heat source and the silicon contact pad for the material use. So next for the second previous study, they use the NC's CFX 20 degrees Celsius. They use the steam improvement heat transfer coefficient for the heat source and the aluminum as the material use. So number 3 for the previous study, they use the star CCM plus. They use the heat conduction for the heat source and the platinum and gold for the material use. And the last for the previous study, they use the NCCFX and the inlet temperature is the 55 degrees Celsius and the heat source they use the heat source as heat flux and the material use is steel. So for the summary for this literature review, the plan of the study, the CFD software that we use is the SolidWorks flow simulation. The inlet for the temperature is 120 degrees Celsius and the different thickness which are 3 mm, 4 mm and 6 mm. So for the material we use the LPDE with the EPDM 60 durometer rubber. Okay, next for the methodology. First we create the flow chart for the simulation. So first we started with the literature review, geometrical modeling, meshing, and the boundary condition. From this, we create the simplify heating pad with the simplified heating pad with the placing tag. And next, the mesh ventilation, flow simulation, and analysis of result and the documentation. And for the boundary condition, we present study which the software of SolidWorks flow simulation. The inlet temperature we use at 120 degrees Celsius. Inlet pressure we use 1 bar, 2 bar, 3 bar, and 4 bar. For the type of flow, is the steady state, and the material use is the LPDE and EPDM 60 durometer rubber. So for the summary, from the methodology, the setup was applied based on the actual planning to calculate the heating pad with the SolidWorks simulation. So next for the result and the discussion. Okay, from the result, the simplified heating pad shows the flow through into inlet and the heat source will through inside the difference thickness tube until throughout to outlet. For the simplified heating pad with the freezing tank, we can see the heat transfer was predetermined critical thermal parameter of the heating pad on the different inlet pressure. So for the summary in this result, the objective of this study to analyze the temperature and the pressure distribution in the heat transfer of the heating pad. The previous study and it is to achieve a comparison between the heat source and the different thickness on the heating pad. Okay, next for the geometry machine. For the summary, mesh quality play an important role in the accuracy of the result. This software used important to examine the measure quality of the element in the mesh. Okay, next for the mesh quality validation graph. The graph of the mesh quality validation shows the different mesh as a different coverage solution to the horizontal mesh. To it can see the goals value changing and the converging on the new value. So this graph shows the mesh quality of the pressure versus levels. Level refinement. So based the graph, there are slightly significant changes of the pressure with the average relative error below 1% in pressure from the level refinement between 6 to 7. So for the summary for this graph, the value of the mesh quality validation of the geometry was achieved, and the mesh quality validation, the data and the result that has been obtained from the value of the simulation. Next for the temperature distribution, so based on this figure, contour of the inner diameter of the thickness 3 mm, 4 mm and 5 mm, that a contour plot temperature distribution to show the heat transfer from the heating pad to the flexi tank through the inlet till the outlet by using the heat source is steam. So next, what we can see, the observing the temperature contour with the same value of the temperature, the color red clearer can be seen the contour from the middle of the parameter in the pressure 1 bar. So next, the parameter 2 bar still located the color at the middle of the flexi tank, followed by the next parameter which is a 3 bar, and the N4 bar. The color contour will changing become the high rise until they achieve the top level of the flexi tank. So for the summary for the temperature distribution, this shows that when increase the pressure will increase the temperature distribution. On this thickness tube, the temperature was achieved and the heat transfer moves speedy. The heat transfer is steady if the thickness tube more than 4 mm. Next for the pressure distribution, for the summary, from this thickness tube, the pressure was appear first when the heat transfer still in less than 4 bar and less than 4 mm. So the progress of the heat transfer of flow the heat source, which is the steam, accordingly with this thickness 4 mm. So based on the table, this tube, the thickness tube, the pressure of contour get a different flow of the heat transfer at 120 degrees Celsius and different bar. Okay, next for the maximum temperature versus pressure. So based on the graph, the maximum temperature was increased with the with the different pressure, which are the 1 bar, 2 bar, 3 bar and 4 bar. So what we can see, the temperature was increased when the thickness tube of 4 mm was increased in 3 bar and will increase at the 4 bar. So for the summary for this graph, the result this graph increased less than 4 bar, and the difference between the pressure was achieved. Next for the maximum temperature versus thickness in the thermometer, which is maximum temperature was set on the 120 degrees Celsius, and then the flow of the thickness in a meter was decreased to the 5 mm, and then the value of 1 bar, 2 bar, 3 bar, and 4 bar was mostly increased at the 3 mm and decreased on the 5 mm. So for the summary on this graph, the value of the thickness show a decrease at the 4 bar, cause the flow suitable with that set temperature. The temperature maximum versus thickness was achieved to compare with which one the thickness can rapidly flow the steam at the set temperature. That's the pressure losses. From the pressure losses, we calculate the value from the heating pad, and then uh, the thickness value of the thickness was increased on the started by of 1 bar to the 4 bar. So the highest of value of the pressure losses, the thickness 3 mm get 400,000, which is the high the height of the value of pressure losses. So for the summary of this graph, the result obtained to relation between the pressure losses on the heating pad become increased with the different thickness tube, which are 3, 4, and 5 mm, and based on the pressure. Next, the conclusion. For the conclusion, first the main in this project to determine the critical thermal parameters of the heating pad and to compare the effects of the heat distribution on the different inlet pressure and thickness tube. So second, the preliminary result from this study proved that heat distribution is an effective way for the temperature melt. Third, the parameter as state in the boundary condition will be observed. Fourth, the study need to be proceed with the detailed study according to the parameter state in methodology to discuss the analysis